Right, composite functions. It's like a function within a function. So I've got two functions here. Instead of calling them both function of x, I can't call them the same thing. So we just use different letters of the alphabet. H of x, that's a function in x, and k of x. I could put g of x. That's often used a lot. F of x is always used. All right, now, what do I substitute into what? What's the master equation here, do you think? K has got the hx substituted into it. See, it's the k of h of x. So I start with the k of x function, and wherever I see an x, I substitute h of x into it. See, you've seen, do you want me to show you what you've seen already? I'll show you what you've already seen. You've seen stuff like this. You don't have to write it down. Oh, you can if you want. Here, you've seen stuff like this. Example. If function of x is 2x minus 3, find function of -1 or something. So you know I'm going to substitute a -1 wherever I see an x. That's what we've done in the past. This is the same sort of thing, but you start with the k function and you substitute the hx in wherever you see an x. So we've got, it's 1 minus 5, and then we sub, so with this one we sub hx into the kx function, because k is the master function or the first function here, and hx is substituted into it. So you start writing out k of x, 1 minus 5 times. Now, what do I put in place of the x? 2x plus 3. Okay? We okay with that? So how do you know which one to start with? The one out the front. And always the thing in the bracket is what gets substituted, just like over here. The -1 gets substituted into this. For this one, function of -1, I just replace an x with -1. Okay? So I'm doing the same thing, but instead of just substituting a number, I substitute an entire function. All right, so what have I got here? 1 minus what? Yep, 1 take away 10x, take away 15, which is -10x minus 14. Okay, now I have to find the h of k of x. So I start with the h function. As soon as I get an x, I have to substitute what k of x is. So I replace the x here with 1 minus 5x, come back, plus 3. So I'm starting with this 2x plus 3, but as soon as I get to the x, I substitute the k of x into it. And expand 2 minus 10x plus 3. I'm going to write this as 5 minus 10x. Now, looking at both these equations, what are both these equations? What's that? What is it? A parabola, a cubic, a straight line, a absolute value graph? It's a straight line, and this? Straight line. They're both straight lines. What is the domain of straight lines? Don't they just continue on forever? Domain. Are they all real x? And that one as well. So therefore the composite function, so therefore both composite functions have domain all real x. Does this make sense? And don't both equations go on and on in the y direction as well? So both composite functions will have, so both k of h of x and h of k of x have domain and range all real x or real y. Okay? K of h of x and h of k of x both have domain and all real x and range all real y. Question 5. Function of x is x plus 1 and g of x is 2x minus 3. You have to find the function of the g of 7. You know, like when you've got things with brackets, don't you do the inside brackets first? What do you want to do first? Do you think you could work out g of 7? G of 7. That is telling you take the g function and substitute x with 7. That'll just give you a number, won't it? So what I'm going to do, so that's the function of, let me work out what g of 7 is. What's g of 7? Just keep the f thing outside. What's g of 7? How do I do it? 2 times 7 minus 3. So it's the function of... So all I've done is substitute 7 into the g function, but I'm still writing out everything as is. All right? So the function of... I haven't touched the function yet, but I'm just working out g of 7 inside here. What do I get? What's 14 minus 3? So it's really asking you for the function of 11. What you could have done, if you want, is just work out g of 7 on the side. You'll get 11, and then just do function of 11. Now what do I do? Which equation do I go to now? F of x and substitute 11, yeah, and I just write it as 11 plus 1, which is 12. Off you go. If you want, you could have, if that's getting too messy, just work out g of 7 first, and you'll get 2 times 7 minus 3, which is 11, and then do function of 11 next. Or this is how you can write it all in one step. And then you go function of 11 is. You can do it like that. But it's good to try and use the notation, okay? Let's try and use the notation. G of, what's this telling you to do? Substitute what into what? Substitute 7 into the fx1. G of 7 plus 1, which is g of 8. Do you know what you're doing now? You know where to substitute? So g of 8 is in this one, 2 times 8 minus 3. 16 minus 3, 13. Try the next two to do the function of 8. Function of 8, which is, you go into this equation. Yeah? What do I write? Function of 8 is 8 plus 1, which is 9. And then you can do the other one too. The g of 7. The g of, we're substituting 7 into this. We've already done that before, but it doesn't matter. 2 times 7 minus 3. So it's the g of 14 minus 3, g of 11. And then you go into the g equation again with 11. (22 minus 3), 19. If function of x is 4x and g of x is the square root of x, find the function of g of x. Now, this is a little bit different to the one we did the other day. If you look at these functions, in the last question we are looking at the domain and range. But, you know, this is just a straight line, like y equals 4x. That's got an unrestricted domain and range. Domain all real x, range all real y. But this one is different. What's the domain for this one? Well, x has to be greater than or equal to 0, and y will therefore will be greater. You can only get a positive answer or a 0 for this as well. So this function on its own has domain and range x greater than or equal to 0, y's got to be greater than or equal to 0. So it's going to have an impact on what we call the composite function down here, its domain and range, okay? So that's why we're looking at this. The example we did yesterday was this, where we had two straight lines and the composite function. What you can do, you can just look at the final function, and that's just the composite function here is just another straight line. So its domain and range will just be all real x, all real y. And this second function here, h of k of x, this composite function. So a composite function is when one function is substituted into the other. That's also a straight line. So both these functions have domain and range, all real x, all real y. So if the two original ones have domain and range, all real x, all real y, the composite ones will as well, okay? So you can, the easiest way to do is look at the final composite function and say, this has domain, all real x, all real y, and so does the other one, okay? So with this second one we're doing today, it's a bit trickier because this first function, capital F of x, has domain and range, all real x, all real y, but the second function doesn't. So there's going to be restrictions on the composite one. to tell what it's going to be, it's easiest just to work out what the composite function is, have a look at it, and then say what the restricted domain and range is. So let's look at this. Function of g of x. So we start with the function, which is 4. And what do we do now? What do we replace? So what do we, instead of an x here, we put g of x. So this x gets replaced with what? Root x. So that's what that one is. Oh, I didn't need that many lines. And g of function of x, what's that? Start with this one. And then replace the x with a 4x. Now, so function of g of x, you start with this basic function. When you get to the x, you replace it with whatever g of x is. This, we start with the g of x function, which is the square root of the x. When we get to the x, we replace it with the 4x. Now, I can simplify that as, what's the square root of 4? That's the square root of 4 times the square root of x, which is 2 root x. Okay, now it says show that f of g of x equals 2 times g of f of x. So why don't we just work out what 2 times g of f of x is. So I'm just going to go 2 times g of f of x is 2 times 2 root x. You okay with that? So I'm starting with the right-hand side because it's a bit, I can manipulate that one, which is 4 root x, which equals, isn't that what we had for f of g of x? Which equals f of g of x. That's how you can set that out. So I started with my right-hand side. 2 times g of f of x is 2 times what I just worked out, 2 root x, which is 4 root x, which happens to equal f of g of x. So therefore, we've shown that 2g of f of x equals f of g of x. Okay? And now we want the domain and range of f of g of x. So here's f of g of x, 4 root x. So f of g of x is 4 root x. What's its domain? Domain. X is greater than, can it be 0? Square root of 0? Greater than, and if you're not sure, just do it on your calc. And the range, so if you can only do 4 times 0 or 4 times a positive number, what's your range going to be? Y is? Or 0. Yeah, because if x is 0, you get y is 0, but you'll never get a negative. You could have a decimal, remember, for x. So it's not necessarily going to be y is greater than 4, if you were thinking that. Because when x is 0, 4 times the square root of 0 is 4 times 0 is 0. So you still can get y is 0. But notice the domain and range here is restricted because of the square root of x. Okay? Question 9 here. These are our two functions. We want the domain and range of f of g of x. So what we're going to do that, let's work out what f of g of x is. We'll look at it and then we'll state the domain and range. We won't do these two individually because it can get a bit complicated like that. Okay? See, because if you look here, the domain really could be any value of x, but for the second function, you can only have x is greater than or equal to 0. So we aren't going to have a restricted domain. So let's have a look. Domain and range of f of g of x. So I've got f of g of x is, so I start with the f function, -5 minus the absolute value of square root of x. Just looking at that, I can, if I want to simplify that, I'd have to do cases. Actually, there's really no cases because x has to be great. You know how normally when you've got, is this thing in here ever going to be negative? No, so I'm not going to really have cases because the square root of x can never be negative. It's always going to be positive. I could just write that as -5 minus root x because root x is positive, so the absolute value of positive is just to write it as it is. Okay? So it's -5 minus root x. In this case, you've only got the one case. Do you know why? Because normally if you've got absolute values, what's in there could be positive or negative. And the first case is when what's in the absolute value is positive and you just write it is. And the second case is when it's negative and you put a negative in front of it because you do the negative of the negative. The thing is, the square root of x is either 0 or positive. So we don't have two cases. That is the only case. This is since square root of x is greater than or equal to 0. Okay? We don't have the other case. Because you cannot take the square root of a negative. That's why. All right? Now, I need the domain and range. What do you think the domain of this is? Oh, I've just written it. Tell me about the x values. They have to be, greater than or equal to 0. But what about the range? Let's look at the range just by substituting a few values. Let's say x was 0. What would you get? -5. Let's say x is, choose some nice numbers. Let's say x was 1. -1 minus square root of 1 is 1. You get -6. Let's say x is 4. You know I'm choosing numbers like that? 4. -5 minus -7. What seems to be happening? What was my first answer? -5? Then what did I get? Sorry, -6, -7, less than, no, what was my first value when x was 0? -5. When x was 0, I got -5. When x is 1, I got -5 minus 1 is -6. Look, when x, and then that's my function of g of x, when it was 0, I got -5. When x was 1, I got -6. When x was 4, I got -7. So what do you think the range is? Y is less than or equal to -5. Okay? Now, sometimes the only other way is if you try and sketch that. But I think it's just easy just to choose values for this particular case. And the last part says explain why g of f of x is the empty function. All right, let's just work out what g of f of x is. G of f of x. Start with the g function, which is the square root. And then what do I substitute in place of the f of x? I put that in. Square root of -5 minus absolute value of x. Now, do you think this is always going to be negative? -5 minus something. This square root of this absolute value of x is positive. So -5 minus 1, -5 minus 2, -5 minus 3. Isn't this less than 0? This is less than 0. This is always negative. So I can say that that is always negative, isn't it? Sorry, this bit. -5 minus absolute value of x is always negative. So therefore this is undefined. Does this make sense? This will never, you can't have this. The square root of, because the -5 minus absolute value of x, so I've taken away the square root sign there, is always negative, it's undefined. Why? Because you cannot square root a negative. It's always negative. So this is undefined. So the square root of -5 minus absolute value of x is undefined, as you cannot square root a negative. So in other words, the function doesn't exist, which is why it's the empty function. Okay? Question 8, you can do the top bit there for homework. I just want to do part B, C, and D. Okay? You can do the substitution. Okay, with question 8, just actually you can try question A now. We're going to do it all. Question 8A. So function of h of -1/4. You start with the function equation, which is negative. What am I going to do? -1 on x is function of h of x, but then you've got to, actually what you can maybe work out what h of -1/4 is first. So -1/(-1/4), is that what you did? which is negative 1 over negative a quarter, because that's your function of h of x there. Your function is negative. Then you put your h of x in, and now I'm doing the substitution. Is that all right? Or no? Which is what? What does that equal? Because h of negative a quarter is 1 over negative a quarter, but the function says to put a negative in front. So what I've written here is the function of h of x first, and then I've put in the negative a quarter in the next step. Yes? Sorry? Yes, it is positive, and it's positive what? No? What's 1 divided by a quarter? It's 1 times 4 over 1, which is 4. How many? 1 divided by a quarter, you can do it on your calculator. How many quarters go into 1? You know, like 10 divided by 2 is 5? 1 divided by a quarter is how many quarters go into 1? It's 4. A negative divided by a negative is a positive. This one, h of function of negative a quarter, we start with this, 1 over. And where the x is, you've got to put what f of x is. So that's the negative x. So this one is 1 over negative x, which is 1 over negative, be careful, what do I do? Negative a quarter. See, this is h of f of x first, and then I'm putting in what the x is. Because look, you start with h, it's 1 over. Then you replace the x with a negative x. But then this is telling me to replace the negative a quarter, the x with a negative quarter. Now what do you get? So it's 1 divided by a quarter, which is what? 4. So you get the same answer for function of h of negative a quarter and h of function of negative a quarter. Now you can do your f of negative a quarter. So what do we do here? The function is that. You might want to just work out, maybe with these, it might be easier to work out, do a bit of working out first and work out what f of negative a quarter is first and h of negative a quarter is, because it's starting to get tricky. So I might just down here, just work out what f of negative a quarter is. What is it? What's f of negative a quarter? It's replacing the x with a negative a quarter. What is it? Negative a quarter, which is a quarter. And I'm just going to put h of negative a quarter down here as well. What have we got for h of negative a quarter? It's 1 over negative a quarter, which is negative 4. Okay. Now, in hindsight, I probably should have worked these out first, right? And then when you come to do this, function of h of negative a quarter, you get negative 4, which is positive 4. It's probably easier and less confusing to work out the middle bracket first. The second one, so then again here, function of negative a quarter is a quarter, and there's your 1 over a quarter is 4. You'll still get the same answers, but it might be less confusing to work these out first. To work out the middle, the internal bracket. All right, how would we do this one? Function of negative a quarter. The function says to put negative, and the function of negative a quarter is just a quarter. So it's negative a quarter. Yeah, that is easier. Yeah, especially with this one. And the h of negative a quarter, there's the h of negative a quarter. Here's the h function. So it's 1 over whatever you got for this answer here, which is negative 4. Is that better? So if you want, first one, I should have done it like this in the first place. Function of h of negative a quarter, the function says to put a negative, and the h of negative a quarter is negative 4, so that's positive 4. That's just a better way to do it. And if I want to redo the second one, h of function of negative a quarter, the h says to put 1 over, and now I see what function of negative a quarter is, and it's a quarter. 1 divided by a quarter is 4. Same answers as above, but I think easier to do it in 2 steps. Show that, so part B, function of x is negative x, h of x is 1 on x. Show that function of h of x equals h of function of x. So we start. Function of h of x. So it's negative. And now I get to the x and I have to replace it with whatever h of x is, which is 1 on x. Okay? And now the h of function of x is, start with h of x, which is 1 over. You get to the x and you replace with what f of x is. Now that is also equal to negative 1 on x. So therefore I can say the function of h of x equals the h of function of x. Now you can put that conclusion there separately, or you can do this like this and you can just write it here at the end if you want. That's another way of doing it, which is commonly used. So you know how I've got h of function of x is that, which is that. I can go now, which equals, I can just write here on the end instead, equals the function of h of x. So I can either write it like that or write therefore function of h of x equals h of function of x. So you either have to put it here or you can write the conclusion like that. All right? Either way. Now, why are they saying for all x not equal to 0? Why? Because you can't have x is 0 in this second function. You can have x is 0 for the first one, but not for the second function. Okay? Now that's going to tell us something about the domain and range. All right? Now, let's do f of, so that was part 1. This is part 2. Show that f of x equals h of x. So, f of x. Here's the f function. So it's negative. And when you get to the x, you've got to put in what? Negative x again, which is x. So you do the negative of, and when you get to x, you've got to replace it with function of x, which is negative x again. And the h of x. So we start writing out the h of x function, which is 1 over. And then instead of writing the x, you write what h of x is, which is 1 over x. Now that's 1 divided by 1 on x, which is 1 times x on 1, which is x. And I can put which equals function of x, or I can write the conclusion. Therefore, function of x equals h of x. Do you like writing it this way? Or no, you prefer a separate conclusion? So you can do either way, but the thing is you've got to do one of them. If you don't do it this way, you must write the conclusion the other way. Okay, now we need the domain and range of f of h of x. So let's look at what f of h of x is. So f of h of x from the earlier part is negative 1 on x. So what's its domain and range? Domain? Does anything stick out to you what x can't be? So it's all real x, comma, x cannot equal 0. Actually, do you recognize the function in terms of its graph? Hyperbola, negative hyperbola. What else? What's the range then? All real y can't equal 0. You'll never get 0 because you'd need a 0 on the numerator to get a 0. Just remember what the hyperbola looks like. That one looks like this. That's what that curve looks like. Okay? And the last question says, describe how the graph of h of x is transformed to obtain the graph of h of function of x. So I'm going to write down what each one is. H of function of x is negative 1 on x. Okay, so I've written down what each one is from earlier part of the question. How is this first graph transformed to obtain this second graph? Let's draw them. Oh, actually, negative. When you put a negative in front, what do you do to the graph? Reflect it where? Which axis? It's actually in the x-axis. Because you know how you'll remember that? You remember the x squared graph. That's the easiest way to remember it. You know how that's y equals x squared and that's y equals negative x squared? That's how you know which axis it's been reflected in. So that's actually a tricky one, this one, because for these graphs, you could actually reflect. So if I look at 1 on x, it's like this. And if I look at negative 1 on x, It's that. You could have actually said to me that you think it was reflected in the y-axis, because that will work as well. But we're going to normally, well, generally, because of the shape of this, it works with x and y reflecting in. But just I would put reflected in the x-axis, because whenever you put a negative in front, you're making all the values negative, which means all the y values are now negative, so it's been reflected. So basically, it's reflected in the x-axis. That goes down there, that goes up there. So in other words, h of x is reflected in the x-axis to give h of f of x. Okay?